The Open Systems Interconnection Model, more commonly known as the OSI model, is an abstractual and logical model to understand how network systems communicate with one another. The model essentially breaks down all the different components present in the network and then divide and categorize them into different layers. I believe it's more of a theoretical model that provides standards and techniques when constructing and formulating a network. At the most basic level, the OSI model explains how the different devices connected to the network talk to each other. As it is equipped with all the standards for network devices and network protocols, it's a really helpful tool to understand and make sense of the network and the different devices interacting within it. The application layer is the layer closest to the end user. It serves as a portal through which users can interact with the network. The layer involves interactions from the user and applications or softwares used. This could be a Google Chrome web browser or an instant messaging application. This layer has the most constraints on data syntax involving user authentication and privacy. All functions at this layer are application specific, for example, email and file transfer applications like Portal and Pushbullet. The presentation layer, also known as the syntax layer, is responsible for translation of data between the application layer and the network. It translates the format of data to a standard specific format understood by the network during sending and receiving, like ASCII to EBCDIC. This helps the network to weed out any compatibility problems that could arise due to incorrect formats of data. It handles compression and encryption of the data it receives for faster data communication and security, respectively. The session layer, which is also known as the port layer, is responsible for the connections between devices. It maintains established connections when 2 points on the network are communicating and terminates the connection when necessary. The sessions established are connected by a port number. It's a form of identity for the session. For example, when connecting to online game servers, you sometimes need to specify the port alongside the IP address. Most ports are not static and can be dynamically assigned to different applications. The main function of this layer is logging of start and end of sessions, which information is a lot of importance for network administrators. The transport layer has a vital job among all layers in making sure all the messages that are being sent and received across the network are error-free and in the right sequence, and that there is no loss or duplications of data during transmit. It also accepts messages from the layers above it, the session layer, and splits it into pieces and sends it along its way to the layer below it, the network layer. It also tracks all the messages, making sure which message belongs to which session. The messages must have a header and a message end flags to make sure the transport layer can make heads or tails of the fragmented messages it received and fix it all back together in the correct sequence before handing it off. The network layer is responsible for checking if the data sent across the network is being sent to the correct node. It knows the network address of all the nodes on the network and makes sure which path the data takes depending on factors like priority of service. If the message seems to be too huge in size to be transmitted at the data link layer, the network layers is responsible for breaking it down into many pieces and then send the broken fragments individually and then reassembling and putting it all back together at the delivery node. One of the functions of this layer is called subnet usage accounting, which tracks the frames forwarded and received, which is important during billing. Make sure and blame this layer the next time you overuse your data plan for being such a keen accountant of it. The data link layer is responsible for establishing and terminating connections between two nodes on the network. Its job mainly is to make sure the data has arrived and sent successfully to its right destination, as well as receiving confirmations from the receiver like, yes, we got the data you sent. It also acts like a traffic intersection cop, making sure the data is being received only where there are buffers available to receive it. Furthermore, It handles media access management, which makes sure the right access is available for the right connection to the physical medium. It also makes sure the frame integrity is intact and free of any errors. The physical layer constitutes of all the physical wiring, cabling, and the physical components that connects all the devices across the network together. For example, the fiber optic or Cat5 cable you find connected to the Etisalat modem at your home, or just the copper wires that connects your landline to the grid. This layer is responsible for the transmission of raw data, data that is in the most unstructured and menial form. It says here that it defines the network topology. What it really means is in what fashion the different devices are connected to one another in the network, what device goes where, and what is allowed to communicate with what.